Good morning, 8th and ninth grade. Yeah, I decided that I would sit down and do this study guide, go over that test with you. So I'm here to get you ready for test tomorrow or today. I don't know which day you're going to do it. That's not important to me. Just get her done, if that's a proper term here. We're ready for study guide 14. And it's not a real big study guide. What's it got? 18, 19 questions. And I will try to explain each one to you. Your test is very similar to this. It's got those definitions in the first, and then it's got a few other questions on it as well. That's similar. So if you make 100 on the study guide, you will be ready for test. A couple of you called me yesterday about the study guide, and I got this little feeling that maybe you were wanting to get the study guide clear in your mind so that you could do your test a day earlier. So great for you. That's okay. Um, I am ready to do the first one in study guide. Oh, someone's calling me now. Let's who's saying. Oh, it says hello. This is, it's just a text, okay? How's that sound? I'll answer that text later. If you open your book to the first page on the transverse waves, the answer for that one is a wave with a direction of propagation that is perpendicular to its direction of oscillation. B, longitude wave, a wave with a direction of a propagation that is parallel to its direction of oscillation. Supersonic speed, any speed that is faster than the speed of sound in the substance of interest. Sonic boom, the sound produced as a result of an object traveling at or above Mach 1. Pitch, an indication of how high or low a sound is, which is primarily determined by the frequency of the sound's waves. Number 2, the engineer is designing a car's horn to test it, and the answer is this. The engineer needs to adjust the electronics to emit sound waves with a shorter wavelength. Think you want to know longer or shorter? The answer is shorter. In number 3, your answer is 349.5. Now I'll give you just a little, I'll let you see the answer key here so that you have an idea of how they work that out. I don't know, is that clear to you? And that shows you the steps of how to go about it. And so if you're right there, we'll look at number 4 too. I'll show you that one. And the answer is 699 hertz. Is that right? I think that's right. So that's 3 and 4. If you got them wrong and you wondered how they worked it out, yes, number 4 is 699 hertz. Number 5. Oh, I should have showed you that one too. It's infrasonic wave. Since the frequency is less than 20 hertz, it's infrasonic waves. And I will again give you just that example. It's on the top of the next page there. Can you see that? Number 6 is the one that two of you called me about, I know. And it says that he will not be able to hear the alarm because without air, the sound waves from the alarm have nothing through which to travel. Thus, they cannot make waves. As a result, there is no sound. If there's not a medium to carry the waves, the sound waves, and that medium can be air, gas, it can be a liquid, it can be a solid, and like we talked about earlier, and you'll need to know this here for test a little bit, you'll need to know this concept that sound waves travel in air at a certain speed. And depending on the temperature of the air, they travel faster or slower. The warmer the air, the faster they go. But did you know that they'll travel faster in water than in air? And I told you this before, but in a solid, they'll go faster yet. So they're wanting to know On number 6. Oh no, that's not the one. That's another answer where they want to know when the sound hits the wall, will it go faster or slower? And it actually go faster in a solid than in the air. That's hard to believe, but that's the way it is. Number 7. Sorry for that little speech there. Number 7. Sound waves are longitudinal waves. Longitudinal. Longitude, if I can say the word right. Number 8 is 339.3 minutes per second. And then your other answer is going to be 780.39. I guess that would be the total answer. Probably for, let me see here, which do you need? 2. And number 8, how far from you will the lightning strike? And the temperature is 13. Yes, 780.39 meters is your answer. 780.39. And again, I'll show you how they figured that example. Where are we at here? There we go. You never know which way I'll hold the book. So right down here, the bottom line is your answer. Number 9, the sound travels faster in the wall. Oh, that's the question I was talking about. And number 10, the amplitude of the wave will be smaller. Number 11, 830.25 meters per second. And then I'll go give you 12's answer right away, and that's 1.4 Mach. And so I'll show you, they have those worked out as well. I'll show you the steps that they took to work those out. And there might be some shortcuts that you could take. I'll let you decide if you know how to do those shortcuts. Okay, and then I am ready for number 13. When a jet travels at Mach 1 or higher, it creates a shock wave of the air that causes a very loud boom. This boom can damage people's ears and buildings. It's talking about the sonic boom. I don't even know what the question. Why does a jet traveling so or higher only in sparsely populated regions? Yes, they only travel where there's not many people and not many buildings, so that when they make that supersonic boom, it does not destroy your ears or break out the windows in your building or in your house. And number 14 on the next page, a guitar player is plucking on a string. If he takes his finger and pinches a string on the neck of the guitar so to shorten the length of the string, will the pitch of the sound increase, decrease, or stay the same? What do you think, Lance? You got any clue there? I'd say for Lance, it's pretty easy. The pitch will increase if you shorten the string. Number 15 is the wavelength, frequency, and speed will all be the same. Okay, the wavelength, the frequency, and the speed will all be the same. And then also the amplitudes of the wave will be different is the last answer. So do you have 2 and 15? What is the aspects? What will be the difference? Okay, what would be the same? Okay, the same is, again, wavelength, frequency, and speed. And the difference is the amps. Number 16. A car travels from you. The sound of the waves are produced by the horn get farther and farther apart. This makes the wavelength seem longer to your ears, which will result in a lower frequency. Thus, the horn pitch is lower when it is moving away from you. That's your answer. It's lower when it's moving away. Number 17, as you travel toward the police car, you will encounter the impressions of the sound waves faster than when you stand still. As a result, the wavelength will seem shorter to you, which will produce higher frequencies. This means the pitch will get higher. So as you go toward it, the sound will get louder, we say. And that means it higher. You know how that works. You've rode in vehicles, you've heard sounds, you've passed them, and as you come closer, it gets louder, and then when you leave, it gets quieter. number 18 is 10 bells. I helped some of you on this one again. And again, I'll show you how he figured it. Oh, wait a minute. Yeah, it's 10 bells, but your answer is probably 100 times larger than the intensity of the sound waves from your voice. 100 times larger. That is number 18. You were standing near the interstate trying to talk on your phone. You raise your voice because of the noise, so the loudness of your voice is about 80 decibels. The sound of the traffic on the highway is about 100 decibels. How many times larger is the intensity of the traffic sound waves compared to those of your voice? Okay, from 80 to 100, you had to go 10 times 10. It would mean 100 times. And then I'll get 19 and I'll show you how they figured those answers. Number 19 is 3 bells. Yeah, the bell scale that every bell unit can put in the factor of 10. Yes, a decibel, every decibel, it takes 10 decibels to get 1 bell. And that is just perfect with your decimal system. The deci in your decimal system is 10 more than the unit, or less, I should say, not more, less. Deca is more. So decibels, it takes 10 of those to make 1 bell. So I will show you how they figured number 18 and number 19. And number 19 is down there on the bottom. Yeah, if you missed any on your study guide, get those corrected. Go through your book and look at your examples, how they figured their problems, because yes, you're right, you'll have to do some math. That's just tests for you. And I think it's 1 page, so you should be able to complete the test in a little bit of no time. And yeah, hand it in this weekend and I'll get it checked. I haven't got your tests from last week checked. They're laying over here on the table, and I looked at them and I didn't even count them. I hope you all returned them. Yeah, I'll find out in a little bit though. I'm missing just a book or two. Not too bad, it's pretty good. So if you have a book or two at home that was supposed to be handed in, every time you hand in a test, you should hand in the light unit so I can look at it. And I know it's not checked, okay? I'm okay with that, that's not a problem. But I still want to see the book to see your work, see that you completed it. Well, you have a good day and enjoy doing your test. I'll talk to you later.